I can hear you.
Okay. Is it better? Is the audio better or not yet? Okay, let me try one thing. Can you hear me better or no?
It's very good now. But it is good.
Okay, it's much better now. Okay, just tell me again if it's not better, if it's if there's a lot of fluctuation in the volume.
You can start from the first.
Okay, I can start from the first. Yeah, sure. So the way to think about Kaggle is it's a electronic notebook. Okay, and you know, like how you could you know, you'll take notes and stuff in your regular notebook. In this electronic notebook, you can load your data, look at your data, do some analysis, and what Kaggle lets you do is it lets you it gives you a free platform. So this is completely free. Okay, let me go back. So you basically just need an email account, and when you log in, you will see some screen like this. Okay, and basically a kernel is nothing but electronic notebook. Okay. Okay, so let me show you one notebook. So this is a notebook for and looking at some images of the eye. Okay, and this is for diabetic retinopathy. Okay, so basically people who have diabetes have a high chance of getting retinopathy. Okay, and so normally how we decide if someone has this disease or not is we take images of their retina, and then like a clinician will say if the person has this disease or not. Okay. Okay, do you see a picture of a normal retina, and then you will see a diabetic retina on the right hand side?
Yes, yes.
Okay, so this is just showing you an example of what happens in the disease. You get some like these wool spots, some white spots, some changes in the blood vessel. Okay, so what we want to do is how severe is the disease? Okay, is it like a normal eye, or is it mild disease, severe disease, or moderate disease? Okay. And so the thing is, there are a lot of patients and there are not enough doctors. Okay, so that is a big problem, like throughout the world. Okay, so what people are trying to say, okay, can we at least get some image processing algorithm to differentiate these categories? The categories were normal, mild, moderate, and severe. Okay, yeah. So you will see some scale here. So 0 is no retinopathy, 1 is mild disease, moderate disease, severe disease, and proliferative diabetic retinopathy. Okay. So in this case, in this notebook, what we are going to try is the goal is can we make an automated system given one image, can you train a system to say what category that image belongs to? Okay. Okay, so this is the goal. So any questions about this?
No.
Sorry, can you say that again?
No question.
Okay, no question. Okay, yeah, go ahead. Okay. So actually, this data set comes from Arvind High Hospital, and they have released this data set because they want people to work on it and then share the solution with them. Okay. So it's actually, let me quickly show you what it is. So the reason they so this competition for this retinopathy is organized by Asia Pacific Teleophthalmology Society. Okay, they put this prize money. Okay, and it's distributed among the top 5 or 6 teams, top 7 teams. I don't know. There's some rule somewhere. Yeah. So currently, okay. So how many people are competing? There are 1,500 teams across the world that are taking part in this competition. Okay, it's an ongoing competition. There are still 2 months left for this competition. Okay, so before but I like this example because it's a good example of like what type of analysis problems there are. Okay, let me go back. Oops. Okay, so in our case, we want to get into these 4 categories. So before we start, we have to be able to load the images and look at some real world images. And I will tell you what all of this is really quickly. So basically, we have a text file which just has the path of all the images. Okay, and it just says, okay. So for each image, you need 2 things, right? And you need where is the image located, and what is the category or diagnosis? So 0, 1, 2, 3, 4. Okay. So this is our input data. Okay. And then we have 3,600 images. Okay. And this is the second competition on iData, and the previous one had much more. It had like 35,000 images. Okay. So when you start with a data set like this, right? Many times you have imbalanced data. So what happens is you have many. I'm just showing you the top 10 here, but imbalanced data means you have more subjects with class 0 and fewer. You don't have say you have 1,000 images, and you don't have equal number of images per class. Okay. So I will tell you how all of this is done. So what this do you see a graph? So you might see some graph here where basically just telling you the number of images per diagnosis. Okay. So for sorry, can you say that again? Was there a question?
No. Please continue.
Okay, go ahead. Okay. Yeah. So basically for class 0, you have 1,700 images. For class 1, you have much fewer. For class 2, you have 1,000. Okay. So now you might ask me, how did I make these images, right? And this is the beauty of this electronic notebook. Say you took notes in class, right? And your friend takes better notes than you. Okay. So you will go to the Xerox shop and Xerox his notebook, right? So the beauty of this electronic notebook is I can share it with you. So basically, it's an electronic notebook somebody has made, some other person has made, and I can just make a copy of it. Okay. And in this notebook, everything is a cell or a box. Okay, either I have some comments or some code. Okay, two things go in the box. So here we just have some notes. Let's go to some real. So when I you might see a blue triangle on the left hand side. So when I click that, I am actually running this code in my electronic notebook. So think of it like when you do MATLAB, you do like the command window, right? And you type a command and you hit enter, and you will get some output, right? And you also have a script, so you can do you can have you can run the whole script, right? Okay. The audio is still okay?
Yes.
Okay, perfect. Yeah. Okay, so this is the beauty. Now I can share my notebook with you. I can run each line step by step. Okay, so I'm just going to say okay, wait 1 second. I need to get some preliminaries. Okay, so you see, I ran this code and it just printed it here. Okay. So you basically run it, you take the code, you run it, and you see the output immediately. Okay. So the language here is basically Python, but it's very easy to get started with it. It's like maybe 50 times easier than MATLAB. Okay, and I will show you like I'll show you a for loop, and it's how easy it is. Okay, so basically I add a box. So I'm just making a list of items. And if you see the code I typed here, I just made a list of some items, like 10 numbers. And the code is like how you would think, right? Say, I have a list of items, and for each item in the list, just print it. So you get the output right here. Okay. So you see my electronic notebook, I will just, if I want to share it with you, I will just save it and send you the path, and then you can access it from anywhere. Okay. Okay. Any questions about this code block and text? Like, so you can add code or you can add text, and this is like something like this. Okay. And okay, so I can't talk up. I can't, so basically here is this is really nice. So I'm going to load 3,000 images. I'm going to read my, I told you earlier I have basically my input is just a CSV file. Let me find it. Where did it go? Yeah. So my input is a CSV file with the diagnosis and then the path of the exam. Okay. What's the best way to think about this? Okay. And what we are And this is the nice thing. All we are doing is, so it looks a little complicated, but it's straightforward. So I want you to be fearless. Okay, this is not hard at all. We have a couple of doctors who are taking part in this competition, and they, you just get used to this, and you will get used to this code, and basically you get by just looking and trying, you will see how this code works. So all we are doing here is we are saying, okay, there is some location where all the images are stored, and there are train images and test images, and I'll tell you the difference. And we basically, just from that directory, we load the images and we read the images. Okay, let me just go back to the kernel, because when I run it one by one, it's a little bit tricky. Here's my this one. Yeah, so this is one really nice thing compared to C. Like other programming languages, it's really, just few lines of code, and I can read all the images. Okay, and I can do displays, make graphs. Okay. So for example, I have something in this case. I have loaded all the information about the images in something called a data frame. Okay, and when I do a length, lengdf, this is just telling me there are how many images there are in my data frame. Okay, so this is how I know there are 3,662 images. Okay. So like in MATLAB, you have a variable. Similarly, you have variables here, and all I did is in data frame is I'm just getting from my CSV file. It has two things. One line per image. One is the path, and then the other thing is the diagnosis. And I just load it into a variable called data frame, and you could call it anything, just data structure or whatever. But here it's called data frame, and then I can check how many images there are. Okay. So any questions so far, or does it make sense what we are trying to do? Wait. I didn't hear that question. Yeah.
Hello.
Yeah. Oh, sorry, there's a lot of echo. How can we do this better?
Can we download these images?
Yes. Okay, yeah, then now I can hear it clearly. Yeah, you can download the images. So basically, this is my notebook, and these are all the images right here.
No, you can download one. Okay, data. You can download this. Yes.
Yeah, you can download everything. Everything I'm showing you, you don't even have to run it on the electronic notebook. You can run it on your own machine. You can run it in the your personal machine, or in any machine in the school. It takes time to install the software. And many times, when I help students get started, most of the time is gone in installing software, right? But yeah, everything is freely available for download. Let me show you where it is. One sec. Even yeah, basically in every competition, all the data can be simply downloaded, and every data set has, they break it up into two sets. So one is called train and test. Okay, so the idea is you make your algorithm, you train your algorithm only on the train set. Okay, and then you want to see how your algorithm does, then you test it on the separate test set. So it's kind of like you don't cheat, you don't cheat with your algorithm. So that's here. And there's always some description, like a CSV file. Train.csv is just the training labels, and labels is just the scores I told you. And train.zip has all the images. It's a big image set. Let me see, I can start downloading it here. So I can tell you the size. Yeah, see, for me, it's about 2 gigabytes. So I have a good connection. For me, it will download in 5 or 6 minutes. Yeah, you can download all the image. Yeah, it's written here actually. The data side is the total data set is 10 GB. Yeah, and I can just can I download just one of them? Okay, it will come when it comes. Let's see. Okay, you can download images. You can work. You can work locally, and yeah, that's whatever. What do I want to talk about? So the one other reason I wanted to show you this is there are 1,500 teams, right, from across the world working on this competition. So there is a very active discussion. So, for example, this person who is a doctor, he has given some tips, and basically each discussion topic is like a thread. Okay, and you see these numbers on the side is like how many votes it got. Okay, so this topic is very popular, so it got 117 votes, right? I can vote it, I can give it 118, and then when you click it, you will see I'll show you the tips. Yeah, so this person is giving he's doing really well. My rank right now is out of 1,500 people, I'm ranked 150. But this person is ranked number 6. Okay, but the competition is still ongoing. So he's giving some tips about what model he used, what experiment he's trying. Okay, and lot of notes, and basically for each experiment what score he got, and people share their ideas all the time. Yeah. Because it's very hard to win. Some people just are doing this all day. I only do it when I have free time, right? Okay, so there's very good discussion on about what are the different ideas you can try, what are the different algorithms you can try. So one question you might have for me is how to get started, right? Okay, so you see on the top here there is competitions, there is data sets, there is kernels. So kernels we saw before. So kernels just means electronic notebooks. There are different discussions, and there is one thing called learn, learn, and when you click on it, you will get basically mini courses. Okay, very short courses you can do at your own pace. Again, everything I show you is free. Okay, this is I just want to show you what everybody is using. Like a lot of people helped me in the past, so it's my turn to help all of you get started in this. Okay, so for example, this mini course will take about 7 hours of your time. Okay, and there are 7 lessons. Okay, when you click on each lesson, guess what? You get a electronic notebook. Okay, and you can the same idea, like everything is already installed, and you can just start trying it out. There are some notes, and then there will be some and there is some notes, and then there is some homework. Like basically they gave you some steps. So basically, like print a float, print an integer, print different numbers, do some addition, blah blah blah. You can do different things. So because like we all realize, for example, I did my master's and PhD, but that time there was in my school there nobody was there to pandas and Python didn't exist. So I learned it from like some websites like this. Okay, so it's become, and new things are coming. So it's like it's up to the students, it's up to us to learn it on our own. Okay. There's also some nice like a small mini course on data visualization. So basically, again, this is 7 hours. There are 11 lessons, and there will be some prerequisites. You need to do the Python course first, and then you can come to the pandas course, and then Python pandas and this data visualization. It's again with just one account, you get access to all of these things. Okay. You just need a basic computer and just have some internet access to do it. And I think you can even monitor your progress, like okay, how did I do in class 1, and you can keep a track of your progress. Any questions about this learn part, and what? So the basic idea is, you learn by trying, right? Like when you start, I'll give you an example. Like when you started playing cricket, right? You didn't study the theory of cricket. You just took the bat and the ball and you started playing, right? Okay. So it's the same thing. It's like instead of me giving you a whole lecture about what is Python and blah blah blah, it's like, okay, you come here and you can just like in 1 hour get an idea of what to do. And there are some exercises here, for example. Okay. And again, every time, and this is the really nice thing. It's an electronic notebook where you can do the exercise, and it will be automatically graded by, or if whatever, yeah. So basically, this is our first Python code. You just press the blue button and you have run this code. Okay. Okay, so that is, let me go back to, okay, so far we talked about, Kaggle and some competitions, and somebody was asked about downloading data sets. I just showed you one data set, but there are 20,000 data sets on this website. Okay, so that is 20,000. So you can say X-ray. So even for X-ray we have oh wow, see, we have more than 10 data sets. Okay, so for example, this is a X-ray of, this is a data set of chest images, and so every data analysis project, right, needs a proper goal, right? So for example, in the diabetic eye competition, we had images and then 4 categories, right? Like mild, moderate, severe disease, or no disease. And same thing for this chest X-ray. I will show you that notebook next. It is is there pneumonia or no pneumonia in the chest images? Okay, that is one data set. And again, you can download these X-ray images. They are in the DICOM format. I believe you have you studied the DICOM format. Right? Okay. Yeah, this is a really nice project. There is a Radiology Society of North America. One thing they want to do in children is, to make sure children are growing at the right age, they are, your bones grow as you grow older, right? Especially for kids. So in this competition, in this data set, they try to predict the age of the child just by looking at the image of the X-ray of the hand. Okay. So that was one thing. Okay, let me show you one more notebook, and then I'll open to questions. Okay, any questions so far? Go on. Is it about notes, you said?
Notes, yes.
Yeah, so basically when you go to the Kaggle website, right, you just click on learn, and you can start with how to say, like some of the, so we are using Python, which is, you can think of as a replacement for MATLAB, to read the images and do some statistics, right? But for each competition, there will be like somebody will prepare like a introduction notebook and with some notes. Okay, so, and this is, so what I wanted to show you is, this is another notebook where we are looking at chest X-rays. Okay, and we are just trying to say if there is one disease called collapsed lung, like the lung collapses and air is on the wrong side. That's a pretty severe disease, and we are trying to say from the image if there is pneumothorax or not. Okay, but basically every competition will have its own little notebook, and for general notes, I can email you the link, but basically just from Kaggle for what to say, for Kaggle.learn for Python. And it also, oh sorry, one thing I forgot is there's also some ideas about, if you want notes for how to get started with analysis, this is really good. And if you want, we can do another session where I can talk some more about, like, okay, what is a model, how do you do data exploration, but right now I just wanted to try, like just get you started with what is available. Yeah. But these are some really nice notes for how to make a model. Like, suppose you want to do a project with this eye data or lung data, then you can read about how to start a model, how to do data exploration, how to build your first model. And you see, this whole thing is only 3 hours. You just need 2 or 3 hours to be able to build your first model. Yeah. And all these notes are created by Dan Becker, who's a PhD data scientist who's working at this company. Yeah, his PhD is actually in econometrics, which is kind of interesting that he's doing that. But we can do another session where I can tell you about what these models are, how they work. Okay. Okay, I wanted to show you one more notebook. So basically in X-ray, it's like, the air is black, the fluid and tissue is gray, and the bone and solids appear white, right? And in this notebook, they just put image, and in the other competition, we were trying to say what category, right? Like 0, 1, 2, 3, 4. In this competition, we are going to try and do some segmentation. So just try to mark the area of the chest where there is disease. And in this case, we have DICOM images. So we have to read the DICOM header. and read the DICOM pixel data also. So if you remember the DICOM format, yeah, you have the modality. So in this case, it's X-ray, but it could be X-ray, CT, or anything, right? And let me just show you one image and show you what. Okay. So now you can see, this is a real X-ray of one of the subjects in this database. Yeah. One thing I forgot to mention is all of this data is anonymized. Okay. So there is no patient name or patient any personal information. These are all anonymized DICOM data sets. So we have some things like we don't have the name of the patient. We know the age of the patient is 38. It's a 38 male, and the size of the image is 1024 by 1024. Okay. Okay. So what this electronic notebook shows you is how to load the DICOM image. Okay. And how to display it in here. And what's the best way to say this? Yeah. So this is one really powerful thing of Python. Like in MATLAB, you would do IM read, right? So to read this DICOM file, I just have one line. So there is a package called PyDICOM, and I just say PyDICOM.dcm read, which is for DICOM read. Okay, so basically this one line, and you just give the path of your image, so that will load your image. And in MATLAB you have image show. So in this case you just have plot to look at your data set. Okay. Yeah. So in this case, many times you will get a data set and you want to look at what the data looks like. Okay. So you can do like you can look at multiple images, as you see here with my mouse. How you can see multiple DICOM images and plot them. But this code might look a little bit scary, but don't be afraid. It's really straightforward. Okay, it's almost like I'm talking to you, right? It's just saying, okay, read the CSV file, because that text file has the information about what is the data, and we are just going to do a for loop and read, like, say 10 images. Oh, is it when I move my mouse you get that noise? Okay, I don't know. Let's see. Okay, and you read the DICOM data and you display it. Okay, it looks complicated, but it's really just a few lines of code, which if you start for like 1 hour, you'll be fine with it. Okay. I don't know if it's easy to see it here, but this X-ray, there is a small region that is. Let me make it bigger. Okay. So I was telling you there is segmentation. So in this case, there is this area segmented where we are trying to. That's the disease area. Okay. And then here we are just doing an overlay of 2 images of the X-ray and the segmentation. Okay. So today I just want to give you an introduction. Okay, so what we talked about so far is this: you have this online platform Kaggle. We have electronic notebooks. You have notebooks. You have data sets, and this is one of the biggest problem in biomedical data analysis, right? Getting a good data set. So for each image you want, okay, what is the age of the person, what is the gender, is there disease or not, right? So you want, like, even in my company, like, a lot of the time we spend just preparing the data set, right? Like 75% of the time just goes in collecting the data from different sources and making all the images of the same size, like that kind of data preparation takes a lot of our time. Okay, so this Kaggle platform gives you the notebooks, the electronic notebooks and the data. And actually, one of the best things it gives you is it gives you a powerful machine. It actually gives you something called a GPU. So normally the machines have a CPU, but for a lot of the data analysis, you need a little bit more powerful machine. So you get a free GPU for about, I think it's like 12 hours a day. Yeah. And then next day you can start again with a new machine. So a lot of us are just, trying out, looking at data sets with this, like on Kaggle. And the whole idea of electronic notebooks is, then I can share like this with you, right? So it's in a web browser, and if I just send you the link, you can go and look at it. You can it's basically called, you will see, like, every notebook has, if it's a, okay, yeah, and of course some people keep it private, so then you don't have this copy and edit option, but you can copy it and start, it's like making a Xerox copy, right? But it's just everything is electronic, and you can get started with it and work with this notebook. Yeah. And there's a lot of, so I was telling Vivek sir in the email that this is the first time I see like 3 biomedical competitions at the same time. The pneumonia competition, the diabetes competition, and there is actually a third one, which is like for cell images. Okay. This is, so there are these 3 competitions. Okay. And basically, we are people put a lot of effort to make these notebooks, and one reason sometimes people do it is this company gives like some prize money for best notebook of the month. So people put a lot of effort to make a good notebook, and so that's why you see it takes a lot of time to make this notebook, and they have done this. Let me show you one more thing. It's my mouse. Oh, sorry, it's my mouse. My mouse has a scroll button, and whenever I scroll, that noise is coming. I'll try to keep it away. Let's see. So let me show you last year's one of the big. So I started doing it seriously last year. Yeah, so these are the current so the blindness, this is the diabetic competition. Oh, I'm ranked 194. My rank fell down in the last few days. I'm ranked 194 out of 1,500. This is the chest X-ray competition. Yeah, these are fewer teams. There's another one for molecular properties about magnetic interactions. And this is the third biomedical competition. Like in the first case, we had X-ray eyes, and in this case, you have microscope. Okay. Oh, and one other really great thing is, even once the competition is over, the data is still available, and you can make a, if you run it, you can make a submission So it's called submit prediction. So there is some rule about how to submit your result. So you have to follow that rule and then submit it. And even after the competition is over, you will still get a score. They keep the, and in the back end, it's automatically, your score is automatically computed. Okay. Let me show you one really cool thing here. Okay. In this also, we are trying to say what type of cell it is. So it's like in the diabetic, we were trying to say category 0, 1, 2, 3. And here we're just trying to say, okay, which type of cell. And we have a similar, we have a training set, and you can load images. And let me just show you some images here. Yeah. Again, similar like plot, if you've done MATLAB, like the plot function, plot.subplots, and then just a for loop to plot different channels. And these are just some cell images, right, in each channel. So you see different parts of the cell. Yeah, and there is some people do some pre-processing using your image processing. So you might do some edge detection on these images. And if you want to do edge detection, is that me or okay? Yeah, if you want to do edge detection, it will basically be like you have to find the Python function for edge detection, and then just figure out how to run it here. Okay. Yeah, in this case they have just so you see, like there are two parts in this thing. One is whatever type of image it is. So you learn to load the data and you visualize the data. You always want to check your data, like what the samples look like. Okay, and you can visualize and then look at multiple samples from each category to see like what the data is, and then you try to do some basic statistics and then do something more fancy. So here they're just doing again. Okay, perfect. So these are some, these are some from different experiments. So you see a small table here, and we are just saying, so some images are cells after treatment and some are before. So it's like well type, negative, and treatment. So mostly you understand what your data is like, and go from there. So you get data sets, you get notebooks, and and then also like the machine to try this out. I don't know. Do you have easy access to like internet or computers in the library now? I haven't been there in a while. Okay, perfect. Yeah. So you just need, and that's the thing. Like sometimes buying an expensive laptop is just not possible. So this is the nice thing. You just need some internet access. Make an account, and that's it. Just get started. And it looks scary, but don't be afraid. Like we have various even some doctors, and like a lot of people are trying this out, and then people are just helping each other online to try out these data sets. Okay. We can. What should we do next? Do you want to see like how to get started? Like, can I continue, or are you getting bored? Can you just come closer to the computer and speak? It's hard to hear. Yeah.
Can you show me one case wherein you have created some of your thing out here, like create a notebook and all this. Okay,
Okay.
like one case at least.
Okay, sure. Uh,
Take a simple case and show how you created that.
okay, sure. Just give me 1 second. I'll just find. Okay, what's the easiest case? I'm just trying to think of a good case to show you. Okay, let's take this one. Okay, yeah, this is a good example because I can talk about. So one of the really nice things is, this algorithm works for images, but it also works for any other. It doesn't have to be biomedical data, right? It can work for any data. So for example, one of the big competitions before was, can you say if the image has a cat or a dog or a lion or some animal? Okay, so that was one type. It can also work for any like stocks data, or it can work for like say house price data. Okay, so this is an easy example where I can quickly show you like how the models are created. Okay, let's say let's say you want to predict the price of a house. Okay. So what are some of the things you would like to measure about the house? You might measure what is the size of the house, how many bedrooms, how many square feet, right? What is the area? Maybe the location. The price depends on where it is. Okay. So you have some data where you have information about the different examples of different houses, and in this case these are like house prices from like city of Melbourne. Okay, and they have the things we expect. It has a number of rooms, the size of bedroom 2, and so on. Okay, and we are trying to predict the price, which is the y variable. Okay, and so what we have done is we have measured various things about each house, right? So these features, so we are going to call them features. Okay, so this is my feature of the house, but you can, so in biomedical problems we normally do features could be like the age of the patient, the gender of the patient. Okay, maybe like what is their blood pressure. That could be a feature. So features are nothing but some property you can measure. Okay, sorry sir. So here it's the number of rooms, and so these are some of the features, and features normally come in the variable x, and what you're trying to predict is y. Okay, so in this case my y is the price of the house, and these x is the features of the house. Okay, but it could easily be like do I have high blood pressure or no? So that, like in biomedical problem, y could be like the blood pressure value, and you could have different features you measure, different data things you measure. You have some basic statistics for each feature, right? Because normally when you do this data analysis, you won't have, 1 or 2 subjects is not enough, or 1 or 2 samples is not enough. You need like at least 1,000 samples. Okay, so in this case we have 6,000 different types of houses. Okay, we know so on average there are about 3 rooms per house. Okay, there is 1.5 bathroom on average, right? And so you can so you have the features, and you have like some properties about the features. Okay. What's the best way to think about it? So you have linear regression in statistics, right? Okay. So the simplest model is basically a regression model. Okay. And you are just trying to see y equal to a1 x1 plus a2 x2 plus a3 x3. Okay. And you try to okay, you're going to try and do regression, right? And you want to fit the model to the data. Okay. So normally when you start, you will start with some assumption. Okay, maybe I will do like a model like regression model, maybe a decision tree model, and don't worry about the details. Like these are just different models, like to try and capture the relation between y and x. Okay, so you have some properties about the house, and you're trying to predict the house, and you're just trying to see, okay, which model will fit the data. So when I first started doing this in 2002, we had to write our own model, but now mostly the model is built. It's already written for you. So in this case, it just becomes one line. It's a one-liner where it's like your model is a decision. This is one specific type of model. Okay. And the model has a function called fit. Okay. And it takes the input x and the predicted y. Okay. And it will create some model. You will always get some output, but now you can ask me the question like, is the model any good? Is it a good model, or is it a useless model, right? So that's why what we do is we always divide the data. I can stop sharing, and I can just share it. It's okay. Okay, so we always divide the data into two parts, like a training part and a testing part. That's why we do two parts, because these algorithms will always give us some answer, but then we don't know if the answer is any good or it's useless. Okay. And it will always give us some answers, and we're like, okay, is this any good or not? So you have a training set, and once you make the model, then you test it. So this is just fitting, right? And then you make prediction. So there is two parts. One is fitting the model, and the second is predicting on a new data set. Okay. Okay. So for example, in this case, these are the but I don't have the. These are some of the predictions for the model. One second. Let me see if there is an evaluation. Basic builder. Okay. Yeah. There. So this is a big thing. This is the basic question, right? Like anybody can make a model, but is your model any good, right? So you need to do some validation. Okay, you need to do some validation, and in this case, it's very simple. In this case, that's why I took this example. We'll measure the mean absolute error, and the definition is very simple. It's basically for each house, what is the actual price minus the predicted price. Okay, and you take the actual minus the predicted, and you take the absolute value. Okay. So for example, if the house cost 150,000, so 1,50,000, and you said it is 1 lakh, so your error is 50,000. Okay. And you just take the absolute value, and you take the average of that. So in this case, the error of our model is 434. So that's actually pretty good. This error is pretty small, 434. But basically, this is an example. So you collect some data. Step 1 was collect data. You have the categories, right? Like disease or healthy or whatever, or in this case, house prices. And you have the Y and X. So the output you want to predict and the features. And you have you fit a model, and then you see how good your model did. Okay. Yeah, and mostly these models are already, you don't have to write them from scratch. Okay. But they're already available. And let me show you this scikit-learn. Okay, so here, do you see like a flowchart? Yeah, perfect. Okay, so basically you start, you see how much data you have. So you need at least 50 samples, maybe more than 50 samples. Okay, and there are two types of problems, and I gave you example of both, right? One is we were trying to say what disease category it is. Is it like diabetes 0, 1, 2, 3, 4? Or we are trying to predict price of a house, right? So sometimes it's a category, and that 1, 2, 3, 4 is not a real number, right? I could have just called it category 1, category 2, or category A, B, C, D. But the price of a house is the real quantity. It has some meaning. Okay. So what this flowchart is showing you actually is like how to make when you start with some data set, how to decide which way you want to go. So when you have the example I gave of the house, you do regression like this. And when you have some classification, when you want to say what category you are, you do some classification. Okay. So these two are the main big categories. Okay. And actually this flowchart is really nice. When I click on this this box, it will take me to the code for that box, like how to run that box, how to run that method. Yeah, so this is kind of how we normally do it. We'll have like a big classification, and like we had to try to predict, is it like classification or not? And in both of this, we have we had some, like for my diabetes example, I had label data. That means some doctor went in, I had 1,000 images, and the doctor actually went in and said if this is diabetes category 1, 2, 3, 4, and they manually labeled the data for me. So they gave me the label data. So sometimes you don't have that, and that is for another time. That's another topic. But all of this, like even the X-ray example I gave of pneumonia and not pneumonia, somebody actually looked at the X-ray and told me, is it pneumonia, yes or no? And normally, like a doctor, like a radiologist, did that. Okay. Yeah. So it's and it takes, it's I don't know, the main lesson is be fearless. Okay, don't be, and it's not like we're not building a website or anything like that. Wait, let me just share, and let me just I don't know if you see me. Okay, so we are not how to say this. Yeah, don't be afraid. Like, it's basically just some data, and you're just going to try and look at what the data is trying to tell you. So sort of like the data is telling you a story, and okay, can you figure out what is the story in the data, or can you get the information from the data? Okay. But if you like, so this is just one part of the biomedical jobs, right? So sometimes you have regulatory stuff, you have actually making the instruments, your medical devices, And then once you make the device, you have to collect the data and show that it works. So this is one particular type. So of course, I'm just focused on this last part, right? Like data collection, data analysis, and like you can see, there is a lot of interest in it from all those competitions I showed you. Actually, one of the models is already deployed in the Apollo hospitals, and they are using it in a couple of hospitals for the diabetes detection, early detection. I didn't go into like all the very small details because it's very it's just not enough time to go into all the small details about the model. But this is how you get started. If you like this kind of stuff, the best place to go is this Kaggle website, and you can get the data, you can get the machine, and like a electronic notebook. Yeah. So yeah, if you and they have tons of tutorials and notebooks. It's just like, okay, how much time you have, right? It's like how do you find time to work on these things? But the data is, you can look at what other people did. You can run other people's notebooks, right? And I'm going to try one thing. Can I? Okay. Yeah. Any questions like about the examples? And let me share that screen again. Yeah. So this is, this all comes after image processing, right? Like you have collected your images, you have done some image processing, you might measure some properties from the images, and once you have this data organized, you can do classification or regression. Yeah. Okay, I'll stop for questions. Yeah, if it looks intimidating, don't be afraid. It's like, it just I'm actually learning things like right now. So for example, I'll show you something. There is a software called Slack. Slack is like how people kind of share information and share knowledge with, basically people make groups and share methods and ideas. So for example, this do you see like you see some window, right? Like with all some boxes on the left hand side and some notes here. Yeah. So what this is this is a group called Data Science India. It has how many people? Let me see. I can't go. Come on. Yeah. So this is there are two groups in India. This is Data Science India. It has 1,200 people, and this other group, Data Science Network, has 1,600 people. So like I said, it's basically everybody's learning at the same time, sort of. It's kind of like when the previous gen, like when my dad was working, they never had to like continuously keep learning. Oops. Oh, sorry about that. And, let me. Okay, do you see my screen, or no? You have a problem with the connection? Oops. Oh, can you still hear me? Oh, it's done. Yeah, yeah.
With the data.
Sorry?
There is a problem with the data.
Oh, okay. I see. Yeah, should we? Yeah. Do you have any questions you would like to, like how to get started, or yeah, it's hard to find time, so you have to figure out, you have to optimize your time to do this kind of things. Okay. And with mostly, yeah, like in the past, the big problem was getting data, but now you can get good data sets quite easily. Yeah. Yeah. Can I try one thing real quick? I just want to try. I want to try like a Google Chat window. Just want to see the quality. Okay, I'll just call you on that. Let me just see if it's a little better.
Account in this.
Sorry?
You don't have account here.
I don't have a Gmail account. Okay, I see. Okay, no problem. Yeah. Okay. Sorry?
That Hangout is a software, huh?
Oh, I see. I see. Okay. No, that's okay. No problem. I'll just share this screen. Okay, I can. Okay. So what do you like? Should we stop here, or like
students are waiting outside.
Okay.
The other students are waiting there. Want to get into the class.
Okay. Yeah, we can do. Okay, I'll end the session here. Okay.
Yeah. Thank you. I think it is. Actually, you passed it in 2002, right?
Sorry?
You passed it in 2002, right?
Yeah, 2000 actually.
2000. He's passed in 2000. 2000? Yeah, he's working in US for last 20 years.
Okay. Okay.
Thank you very much. I'll get back to you again.
Okay.
If there is a difficulty, I'll get back to you again. I will go through your projects, and students are selecting their project based on your advice that you just suggested.
Okay. Sounds good. Yeah.
Definitely it is useful and it is their project selection time, so definitely it will be useful for them.
Yeah, the data is really good, so it's good data sets, big data sets. Yeah, they can be used for projects.
Data sets. I think that's all a good website. I think you can download those data sets and work offline also. Online is possible, offline.
Okay. Yeah.
Thank you.